Okay, so we are now on page 43. Okay, page 43, and we are getting to the Pythagorean theorem, specifically how to use it, where it comes from. We've already started using it. You've already seen it already. Okay, so here is investigation 3. The focus question is, let's see, oops, no, it's down there. What is the relationship between the square of each side length of a triangle? Okay, so we already know the relationship between the side lengths themselves, but now we're going to talk about the relationships of the squares of the side length of each triangle. Okay, for example, acute triangles. We'll define these. We'll talk about the side lengths in a little bit. We know that acute triangles are triangles with 3 angles that are all less than 90. Okay, so this is triangles with three angles less than 90 degrees. Okay. And then we've got an obtuse triangle where there's a triangle with one angle that is more than 90 degrees. You can't have it with 2 or more angles that are more than 90. Okay, it doesn't work. Okay. A right triangle is a triangle with exactly one angle that is 90 degrees. Okay. A hypotenuse is the longest side of a right triangle. Okay? It should always be opposite of the right angle. Okay. And lastly, a leg is the two shorter sides of a right triangle, or it could be any side of a triangle that is not a right triangle. So if it's not a right triangle, every side length is considered a leg. In a right triangle, okay, it is only representing, so this represents our right triangle. Okay, the hypotenuse should always be opposite the right angle. That's this part of the hypotenuse, the longest side, and the legs are the two shorter sides. Now, if I have a triangle that's not a right triangle, okay, then I can have legs that represent all sides. So a leg could be this side, it could be this side, and it is that side. It's all sides, as long as it's not a right triangle. If it's a right triangle, it's specifically the two shorter sides. Okay, so they ask some questions here. Read them over, think about them, but I'm not going to write them down just for the sake of time. What are some characteristics that all triangles share? They have 3 sides and 3 angles. All angles equal 180. The sum of the two shorter sides have to be longer than a third, but less than the difference. How do the 3 side lengths of a triangle relate to each other? Oh, we'll talk about that one. Okay. How do the 3 side lengths of a triangle relate to each other? We know that the sum of the two shorter sides need to be greater than the third. Okay? It needs to be larger than the third side. But good? Okay. So 3 plus 4, is that bigger than 7? Yes, it'll make a triangle. 1 plus 2, is that bigger than 3? No, it's equal to 3. So this will not make a triangle. Okay, for example, if this side length was 3, and then I had a side length of 1 and a side length of 2, they would touch and they would lie flat. They would lie completely flat and it'd be a straight line on top of another straight line. Okay, 6, 8, and 10. 6 plus 8 is 14. It's bigger than 10. This makes a triangle. It looks like this. If this is the 10, there's here's my 6 side length, and there's my 8 side length. Okay, and 6 plus 4 is 10. Is that bigger than 8? Yes. Here's my 8. Here's my 6, and there's my 4. Okay, it'll look something like that. Okay, all right. Now, it says investigating the Pythagorean theorem. So talking about side lengths, okay, and we know the names of these parts now. This is called the hypotenuse. And for a lot of you, this is side length C. Okay, these are our legs. Usually the shorter leg will be named A. Okay, so I'll call this leg A. I'll call this side here they're the same, leg B. Okay, and this is our right angle right here. Okay, our legs are attached to the right angle. Okay, so maybe some side notes. Legs are touching the right angle. The hypotenuse is not. Hypotenuse is not. Okay. Legs are your shorter sides. Okay. Now, here, what they did was they found the longest side, which we called the hypotenuse. Okay. And they made it into a square. Okay. So we can call this hypotenuse. Hypotenuse squared. Or for short, since it's side length C, we can call this C squared. Okay, let's make this a little bit easier to see. So this area here in the middle, we can call that C squared. Or hypotenuse squared. Now, on the next drawing, they have the same thing all over again, so let's just copy this over here. Okay, there's hypotenuse squared. And this one down here to the right, okay, this one down here to the right, we'll call leg A squared, or what is simply called A squared. This is called A squared. And then this one over here, we'll call leg B squared, because it's in the shape of a square. Okay, we'll call this B squared. Now, we do know a couple things. We know that A squared is a 1 by 1. We know A squared is equal to 1 unit. We know B squared is also equal to 1 unit. Well, let's figure out what C squared is. Well, it's got, let's zoom in here. It has a triangle that is a 2 by 1. So that makes this 1 unit and 1 unit. Okay. So then we've got C squared, which is 2. Okay. So A squared plus B squared equals C squared. Okay. I'm going to break your video down into 2 parts. I'm going to pause it right here.